Section 3.4, using the slope to graph linear equations. So sketch the line that has a slope of -3/4 and a y-intercept of 0, 2, 0, -2. So the first thing I'm going to do with that slope is I'm going to write the slope as the change in y over the change in x. And then I'm going to fill it in as a vertical fraction. And once I do that, I'm going to start thinking of the numerator as the change in y and the denominator as the change in x. But that's going from one point on a line to another. So in order to use that to graph, you need a starting point. And they gave us the y-intercept of 0, -2. So we have this one specific point, 0, -2, and then from there, we're going to go over 4, because that's the change in x, and down because of the -3, and that'll be another point on the line. So let's see, we're going to start down and then our y is going to go down. So I'm going to put my horizontal axis up a little higher than the middle, and I'm going to put my vertical axis a little bit to the left of the middle. So when you're using slope to graph, you're always going to move to the right. So it's good to have room to the right of wherever you're starting. So I'm putting the starting point kind of on the left. And then the slope is going to tell you whether you're going up or down. A negative slope is going to go down. So I'm starting at a negative and I'm going down, so I want to have room for that. And if you think that through ahead of time, a lot of times you can use the standard scale of 1 and make your graphing a little bit easier. Okay, so I'm going to start at this point over 0 and down 2, and then from there my x is going to change by 4, so go over 1, 2, 3, 4, starting from the point that you were given, and then my y is going to change by 3, so because that's negative I'm going to go down 1, 2, 3. So there's the change in x of 4 and the change in y of -3. That should be another point on the line. Once I have 2 points on the line, I can bring in some sort of straight edge and then draw in the line from there. And that's the idea of using slope to help us graph a line. Now, one drawback about this is if you're doing an application, your slope isn't always nice numbers. Sometimes it's a messy decimal, and sometimes your scale for the application isn't 1, 2, 3, 4, 5, so counting squares can be awkward. So here's another little trick that you don't see too often. But if this is the change in x is +4, then you could take your x coordinate and you could add 4. And here's your starting y coordinate. Now you're going to change that y by -3, so you could add -3 to that. And if we do that, what's the new point that we get? 0 plus 4 is 5, and -2 plus -3 is -5, so where should we have ended up? At 5, -5. Starting from the origin over 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. So I missed. Oh, because I didn't do the math very well. Don't know where I came up with that 5. 0 plus 4 is 4, of course. So let's try that again. Over 4, down 5. I guess one of the benefits of doing it two ways is double checking, and I caught my mistake, right? So again, starting at the origin, over 4 and down 5, that's the same point we got if we started at 0, -2 and used the slope to go over 4 because that was the change in x, and down 3. So you can count out squares if the numbers are nice. You can do the math on an ordered pair if the numbers are messier. You can do the math if the numbers are nice as well. All right, let's look at another example. Determine the slope and the y-intercept, and then sketch the graph of y equals 5/2 x minus 3. When you hear those directions, those of you who have had algebra before might think, oh, I know what the slope and the y-intercept are just by looking at the equation. But we haven't figured that out together yet, so I'm going to kind of just work out from the equation what's the slope and the y-intercept, and you should see that agrees with what you know from previous classes. And if you haven't had that before, that's fine. I'll show you right now. When you're going to find the y-intercept, what you want to remember is that the y-intercept always has an x-coordinate of 0. So you plug in 0 and you find y, and this ordered pair would be the y-intercept. So we go to that equation and we do y equals 5/2 times the input here of 0 minus 3. And 0 times 5/2 cancels all that out, and we just get y equals -3. So the y-intercept is 0, -3. Now to find another point, kind of mentioned earlier it's good to use a multiple of the denominator when you're plugging in. So let me plug in 6. If I plug in 6, I get y equals 5/2 times 6/1 minus 3. And then this 2 goes into that 6 3 times. And I get y equals 15 minus 3, or 12. Okay, and so now, if I want to find the slope is m, and it's the change in y over the change in x. So I could do 12 minus 3, and then on the top, because I started with this y-coordinate, on the bottom I have to start with this x-coordinate, so 6 minus 0. Two negatives there make a positive, so 12 plus 3 over 6, or 15 over 6, or if we reduce it, this 6 and 15 have a 3 in common. 3 goes into there twice and into there 5 times. So that reduces to 5/2. And now we should be at the point that those of you who have had algebra before kind of saw already. The slope ended up being this coefficient in front of the x, and the y-intercept ended up being 0 together with this number right here. And it turns out that's not a coincidence. That happens all the time. So on future problems, if y is by itself and they ask you for the slope, it's whatever number is the coefficient of x. If they ask for the y-intercept, that'll always have a 0 for the x-coordinate, and the y-coordinate will be this constant right here, including the sign. All right, so there is our slope and y-intercept. We labeled the slope. I think it's always good to label answers when they ask for them. So here's our y-intercept, that 0, -3. But they also asked us to sketch the graph. So we want to use the idea that the slope is change in y over change in x. So change in y over change in x is +5/2. So I'm going to draw in my axis to the left, and then let's see, I'm starting down, but the slope is positive, so I'm going to move up. So kind of in the middle-ish would be fine, I think. So here's my x and my y, and I think none of the numbers, well, this number's big, but we don't have to plot that number. We just have to graph our line. So these numbers are small, so I'm going to just number in ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, -5, and 1, 2, 3, 4, 5. All right, so I'm going to start at the y-intercept, over 0, down 3, right there. And then, because the slope is 5/2, the change in x is +2. So I'm going to go from this point I started at over 2 units, and then I'm going to go from there, the change in y is +5, so up 5, up 1, 2, 3, 4, 5. And that should be another point on the line. 2 points on the line is enough to graph it. So I bring in the straight edge, line it up with those 2 spots, and draw the line. So it's similar to this problem up here, but on this problem they gave us the y-intercept, and we started there and then counted squares using the change in y over change in x. On this problem they didn't give us the slope and y-intercept directly, so we had to work for them, and then once we got them we still plotted the intercept and then used the change in y over change in x idea over 2 and up 5. You can tell whether this is an over or up move because it's the change in x, so it's horizontal. The top is the change in y, so that's vertical. And then if we wanted to do it in the math way that I showed you on the one up above, we could do that as well. Start at 0, -3, and then take the slope. The change in y is 5, so add 5 to the y-coordinate. The change in x is 2, so add 2 to the x-coordinate. And what would the new point be if you did that? 0 plus 2, let's see if I can do the math better this time, is 2, and negative 3 plus 5 is 2. So that should have been where we ended up when we counted squares, over 2, up 2. All right, so a lot of extra work here that some of you probably think was a waste of time because you already knew the slope and intercept, but not everybody knew that. So now we see kind of where that comes from. We'll all kind of state that as an official fact on the next page, and then we can all use that shortcut on future problems. All right, so here's a summary of some of that stuff that we learned on the previous page. If you're finding the slope and y-intercept from a linear equation, then if they give you an equation in the form y equals mx plus b, then the slope of the line is always m, or that coefficient of x. And the y-intercept, you have to remember it's an ordered pair, and for the y-intercept it's always a 0, and then the y-coordinate is whatever this number is right here. Remember that does include the sign, so that's important if this is negative. So if the y is by itself, we say that slope-intercept form, and then you can just look at the slope and look at the key part of the y-intercept. And if somebody asks you to graph an equation that's in slope-intercept form, then one possible way to do that is to figure out the y-intercept and plot that, and then use the rise over run, or change in y over change in x, to plot the second point. So for example, if m is 2/3, then count 3 units to the right from this point, the y-intercept, and then 2 units up, and plot another point, and then sketch the line that goes through those 2 points. The only thing I would change is rise over run isn't language that people use too much. So I would say change in y over change in x is 2/3. So you change your x 3, so you go over 3, and then you change your y 2, so you go up 2. It's the same idea as what they said, just thinking of change in y over change in x instead of rise over run, which really mean the same thing, just a different way of saying it. All right, so let's try it. Determine the slope and the y-intercept, and then sketch the graph of y equals negative 2x minus 1. So the slope is whatever is in front of the x, which would be that piece right there. So the slope, or m, is negative 2. And then the y-intercept is always 0 comma something. So 0 comma what? Whatever the constant is over here, including the sign. So 0, negative 1. So then we can do our graph. Do this one fairly quick. Throw in our 2 axes. Let's see, we are starting down and moving down, so I'll draw the x-axis a little higher. Here's my x, here's my y, 1, 2, 3, 4, 5, 1, 2, 3, 4, negative 5, and then where are we starting? Over 0, down 1. How are we moving? Well, there's no fraction there, so a little bit of thought on that. So some scratch work here. And this is fine for like, what is the slope? That's our answer. What is the y-intercept? That's our answer. But when you're graphing, you want to think of the slope as change in y over change in x, which means you want to think of it as a fraction. If it's not a fraction, just put it over 1, and then it is. So the change in x is 1, so from the first point, move over 1, and then the change in y is negative 2, so go down 2, and there's your second point. Can bring in our straight edge and draw a line. And again, you only have to do this one way, but I'll show you the other way just as confirmation, and so you're comfortable with both. That was our starting point, and then we're going to change x by 1, so we're going to add 1, and we're going to change y by negative 2. And when you do that, 0 plus 1 is 1. Negative 1 minus 2 is negative 3, so that should have been where we ended up with our second point. This is an ordered pair, so start from the origin, over 1, down 1, 2, 3, and that is a match with when we use the counting squares method. All right, let's look at one final example. The average monthly employee contribution to cover a family in an employer-sponsored health plan is shown in the table for various years. Let A be the average monthly employee contribution in dollars to cover a family in an employer-sponsored health plan at T years since 2000. A reasonable model of the situation is A equals 19T plus 139. All right, so they're going to want us to set up a graphing calculator window. They're also going to want us to graph the model by hand. I actually like to do it by hand first because that helps me set up my window that they're asking about here. So I'm going to do that. And when they say graph the model, we need to think about what do they mean by the model. So when they say the model, sometimes people think, oh, I need to plot these ordered pairs. That's actually the data set. That would be a scattergram. When they say to graph the model, they're talking about the equation, and you can actually see that because they say that's a reasonable model. The reasonable model is that equation. So they're talking about the equation, and based on the type of equation we have there, that means we're going to be graphing a line. So when you have an equation, what's the best way to graph a line? Well, I think the best way is to make a table. And so we need to know input, output. This variable is in there mixing it up with the other numbers, so that's the independent and our input, and the one by itself is the dependent or our output. So our table should look like this, T and A. I think an easy number to start with always is a 0 if it makes sense, so let's think about that. One way to think about that is think about what these variables are. So what are these? These are average monthly employee contributions, and if we read through there, that's the variable A. So this is the variable A right here. So there's a thought maybe that this is the variable T, but if you look at it, T is the number of years since 2000. So these are the years, we need the years since 2000. So I'm going to add another column, which will be the T column. And remember, the way you get values of T is you take the year that you're talking about and subtract 2000 away. So 2000 minus 2000 is 0. 2002 is 2 years after. This is 4 years after, and 6 years after, and 8, 10, and 11. All of these come from subtracting. So you take the year that you're looking at, 2011, subtract the starting point, which is 2000, and there's our T equals 11. All right, so is 0 a reasonable thing to plug into our equation? Yes, we have values like that here. Okay, so if I plug that in, what should I get? Well, when you plug in 0, you're getting the y-intercept, and that should be, based on what we learned in previous sections, this number right here. So let's think about that. Plug in a 0 for t. 19 times 0 is 0, plus 139 is 139. So we could plot that, and then if we get at least one other one, we could draw the line in. It's good to have some extras. Let's throw something in like 5. So what would we do to get that one? Well, we would plug 5 into the equation. So the equation is right up here. This is the value of t, so 19 times 5 plus 139 is 234. Now, they also say to make sure there's room for a cost of $400, and we don't have anything that high yet. So let's do some other plugging in. Let's try 10 and see what we get. So if I do 19 times 10 plus 139, that's 329. And now let me play around with some other numbers. What if I did 12? Not there yet. What if I did 14? That would do it, 405. So I'm going to put that one on my table too. If t is 14, we got out 405 from the equation. If they want us to make sure that there's a room for something as big as 400, it would be nice if we graph something that's a little bigger than 400, because then we're going to make sure it fits in our scale. All right, so now let's set up our axes. So draw in our vertical and our horizontal axis. The input variable was t, so that'll be the horizontal axis. The output variable of the equation was a, so that'll be the vertical axis. And then we need to decide on what scale to use. So if you count the squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, that's kind of perfect with our biggest number. So we can just number in ones. And then our last notch will be 14. So we'll be able to do that. And then on the vertical, the minimum is closer to 0 than it is to the max of 405. So I'm going to take the max divided by the number of squares. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 squares. So if I took 405 and divide it by 11 squares, I get 36.8. I don't want to use that as my scale, so I'll round that up to something nice, maybe 40 or 50. I'll just go with 40. So 40, 80, 120, 160, 200, 240. 3 more would get us to 360. And this would be 400 and 440. All right, so now we can plot our ordered pairs that we have. Over 0, up 139. This is 120, that's 160. So 139 is about halfway in between. Over 5, up 234, so just a little bit below the 240 mark. Over to 10, up to 329. So let's see, 280, 320. So 329 is just a little bit above. And notice those seem to be lining up, which is a good sign. And then over to 14 and up to 405. So this is 400, this is 440, so 405 is just a little bit above the 400 mark. And then bring in our straight edge, and hopefully these all line up. Sometimes they won't line up perfectly because you're not plotting your points perfectly, but they should at least be pretty close, and these look like they're pretty good. So there is the graph of the model. I used ordered pairs that I got from the equation. I did not use the data values themselves, okay, because they didn't ask me to draw a scatter diagram. They asked me to graph the model, and by that they meant the equation. All right, so now let's think about if we were going to duplicate that on the graphing calculator, then how would we set up our window? So the calculator never refers to variables other than x and y. So when they refer to the x, min, and max, they mean your input. So my input variable went from 0 to 14. And I used a scale on that, 1, 2, 3, 4, 5, where each notch was 1. For the y value, that's always referring to the dependent or output variable, which on this equation was a. So our a values went from 0 up to 440. And we made every square worth 40, right? 40, 80, 120. So that would be graphing calculator settings that would make this match up. So I don't see them asking me to do this here, but let's draw this on the graphing calculator so that we can see that we have a good match. So first thing is let's set up the window. So let's go from 0 to 14 with a scale of 1. And then from 0 to 440 with a scale of 40. And again, don't worry about resolution. And then hit y equals, even though you don't have a y in your equation, we have to pretend this is a y and pretend the input is the x. So y equals 19 times, instead of t, do the x, plus 139. On the graphing calculator, your input always has to be the x and the output is the y. And then hit graph, and we should see something fairly similar to what we drew. Those look like reasonably good matches. Now they didn't ask us to do this, but is that really a good fit for this data? So this is extra. Let me go ahead and show you what we could do to check on that. You want to go ahead and get this data entered into the calculator, so you're going to press the stat key. Let me move this up a little bit. So you press the stat key, and then you want to go in the edit menus. I already have some other numbers in there, so just remember to clear those out. You use the up arrow to highlight the list, press clear and down arrow, and then I would put these into L1, so 0, 2, 4, 6, 8, 10, and 11, and then in Y2 I would enter these values, so 135, 178, and so on. All right, and then once you get those in there, you want to make sure this data plot. So if you hit y equals, you want to make sure your plot is turned on. From other stuff we've done, it should already be set up to do scatter plots. So just arrow up to get plot 1 highlighted, press enter so that that now is kind of shaded or highlighted. And when you hit graph now, you should see the points and the line. And that's nice to see because now we can tell that the model is doing a pretty good job of lining up with the actual data. But if you look at the problem itself, it didn't ask us to do a scatter, so just when it said to graph the model, that was just the equation. All right, there was one part left on this, so let's take a look at that. Use the graph to estimate when the average monthly employee contribution in dollars to cover a family will be $400. So what we would do for that is $400 is a cost. So we'd go to 400 on the A-axis, which was the dollars, and we would go across from 400 until we hit the graph. And that should happen just a little bit before this line, because that dot was a tiny bit above. And you would drop down and say, what is your t there? So maybe t is approximately 13.8 or something like that. But when you're on My Math Lab, they'll almost always say round that to the nearest whole year. So if we round it to the nearest whole year, that'd be 14. But when they say when, and all the original data was in years, like calendar years, you want to do that here too. So this was 14 years after the year 2000. So we want to take that starting point of 2000. Yeah, sorry, that was right, 2000, and then add 14. So 2014. So I would say it's going to be about in the year 2014. Now, one of the nice things about having put that in the calculator is if we bring the calculator back in and we hit the trace key, it'll put us on our plot at first, which is the data values itself, so it'll jump from square to square. But if you hit down arrow, it'll switch it to the line. And if you move around on the line, it's telling you the x and the y, and here's the y value, which is the cost. So I just want to get that as close as I can to 400. So I'm moving across on the line, still under 400, 399.3, and then 402. So 399.3 happens at 13.7, 402 happens at 13.85. So somewhere in between 13.85 and 13.7 is when you get to 400. From our graph, we guessed 13.8, so I'd say we did a pretty good job based on this graph. But when you use the graphing calculator, it does tend to be a little bit more accurate. All right, let's take a look at this last example. Find an equation of the line that has a slope of m equals 3/4 and a y-intercept of 0, -2. All right, so this is going to be a big goal for us in the class, is to find equations of lines. There's no easier case than the case where they tell you the slope and they tell you the y-intercept, because our lines have the form y equals mx plus b. If you can figure out m and you can figure out b, you can plug them in and you've got the equation. Well, they told you what m is, so that couldn't be easier. This is almost telling you what b is, because remember, the y-intercept is 0, b. So the zeros match, so the b must be -2. So we had to think a little bit about what b is. They told us what m is, and now we just plug that into the equation. So y equals, instead of m, 3/4, keep the x in there, and then plus b, but it's a negative, so I'll write -2, because plus -2, if you simplified that, would just be -2. So there's the simplest form of finding an equation. As we continue on in further sections and chapters, we'll learn to figure out equations in lots of more different situations. In fact, one of our big goals will be to figure out how did they look at data like this and figure out this equation would be a good model. Now, we're not ready for that yet, but we'll get there. All right, that wraps up section 3.4.